a little bit to compounds. So I'm going to skip a line and I'm going to say compounds. You're going to see that the definition and description of element and compounds are similar because we're going to word them the same way, but there's some distinct differences. For example, a compound, since an element contains only one type of atom, a compound contains two or more. So exactly that, contains two or more types of atoms. Contains two or more types of atoms. A compound is not like an element. We can rip a compound apart. But a compound, in order to rip it apart, we have to use a chemical method. So it can be broken down chemically, but not physically. So that means with water. So water is an H2O. Looking for a piece of paper I can write on? Anywhere. So water is H2O. We cannot physically tear this apart. But if we add some electricity plus electricity, I can't spell electricity, the electricity, focus, the electricity would cause, I'm trying to get it to focus, guys. Look up and it's all out of focus. The electricity would cause the water to rip apart. And when the water rips apart, you would get hydrogen and oxygen. It's cool when we do this reaction, and I hope that, well, you will see it. Online learners, you'll see it. I'll make sure and post videos of this reaction. I'm hoping I can show the kids in class because sometimes it can be hard to see because the bubbles are little. But you can see on one, you put two pieces of metal, positive and a negative, into the water, and you pass electricity through the water, so they're not actually touching. You'll see bubbles form, and on one of them the bubbles forming are just oxygen, and on the other one the bubbles forming are just hydrogen, so you can actually see it. Like I said, you'll see that next week when we do chemical reactions. So it can be broken down chemically but not physically, and it has, holy cow, this isn't the best setup. It has sorry, I'm trying to focus the camera. It has different properties. It has different properties than the elements that are in it. So that means, just like we talked about water, water is made up of hydrogen and oxygen. Well, in the air that you're in, the room you're in right now, you have hydrogen and oxygen in the air. Way less hydrogen than oxygen. But the air is gas. Whereas if you went to the sink, you could also get some water in a glass. And so the properties of the water in your room would be liquid, and the physical properties of the gas, or the hydrogen and oxygen in the air, is a gas. So they don't have the same properties. So let's draw some pictures. First of all, words or symbols. These are called chemical formulas. So I'm going to formulas like H2O. That is a formula. Another one that you're going to be familiar with and that you will have tasted probably this morning for breakfast is NaCl. Na is sodium, Cl is chlorine. So you stick them together, you bond them together, and it's sodium chloride. So it's salt, it's table salt, same thing you put on food. The last one is going to be C6H12O6. Most kids love this compound. I can say that I'm pretty fond of it too. It's very tasty, but this compound right here is just a sugar. It's a carbohydrate. Anytime you see CHO together, it's a carbohydrate in chemistry. So let's draw a simple a simple example, just like we had a simple example up here. But to do a simple example, now we had to have 2 or more. So we have to have 2 or more different atoms. So you symbolize that by having 2 different colors of circles joined together. It looks a lot like a molecule, but these are 2 different instead of 2 of the same. So since they're 2 different, I'm going to draw my red bubbles. Since there's 2 different, it makes it a compound. Let's step up our game a little bit. We're going to draw Mickey Mouse. And I say we're going to draw Mickey Mouse because water looks like Mickey Mouse. Because water is H2O. So we have an H, or we have an O, sorry. The O is kind of big. So I'm going to draw some O's. The O is kind of big. And then we have the H's. And for each O, we have 2 H's. So off the top, you draw the little Mickey Mouse ears. But it doesn't just have to be off the top. It can also be off the bottom or the sides. Because, you know, water is kind of mixed up. It doesn't just grow on one side. So it kind of looks like Mickey Mouse. Look, I'm aware Mickey Mouse is not orange and blue. But I chose orange and blue because I like orange. Elements, we drew shapes. We need to draw shapes here. But in order for the shapes to represent a compound, it must contain 2 or more types of shapes. So I draw horrible looking goldfish. And I say horrible looking goldfish because goldfish are not blue. So I draw a circle and a triangle that is stuck to the bottom. If you drew a little smiley face, you'd have an awkward goldfish. Yeah. So I'm just going to draw a few. So you have these goldfish, and just like before, they do not face the same way because they're mixed up. Your compounds and the little atoms and stuff and compounds and elements are going to be mixed up, facing all different directions. All right, so we are now 18 minutes into the video, and we have one left.